Hello, I'm Don Mackholz, and you're listening to Looking Up with Don. This is the Looking Up with Don podcast, episode number 44, for the week of November 4th, 2020. The related website for this podcast is donmachholz.com. That is spelled DONMACHHOLZ.com. 2 H's. What's up in the sky this week? As our week begins on Wednesday, November 4th, the moon is 85% full and rising a couple hours after evening twilight. By the end of our week, Tuesday, November 10th, the moon will be a crescent in the morning sky. This is a good week to get out and observe those bright evening planets, Jupiter, Saturn, and Mars. It's not too late to see these planets, but time is running out. Jupiter and Saturn are now within 5 degrees of each other. In less than 2 months, they will be very close to each other, only 7 arc minutes. A meteor shower is building in the evening sky and will peak next week on November 11th. It is called the Northern Taurids, and the meteors appear to come from the constellation Taurus. This part of the sky is low in the east as the sky darkens, and it's at its highest in the sky just after midnight. While the number of meteors you can see is few, about 5 per hour, this shower is known for producing fireballs. That's bright meteors. So when you go out these evenings for observing, keep an eye open for these meteors. That's right, one eye looking through the telescope and the other eye looking for meteors. Multi-task. If you want to see how Betelgeuse is doing these nights, it rises a couple hours after the sky darkens. I tried watching for birds flying in front of the full moon, as I suggested last week, and saw only one bird this time in 20 minutes of watching. In the morning sky, we have the winter Milky Way, plus those Leo and Virgo galaxies are up in the east before morning twilight. Will you be able to see the International Space Station this week, which for our purposes begins Wednesday, November 4th through Tuesday, November 10th? Well, it all depends upon your location. This week we have 5 zones. For those living north of about 35 degrees north, the ISS will be in your morning sky all week long, and some mornings you'll be able to see it twice. From 20 to 35 degrees north, the International Space Station will be in your morning sky only for the second half of the week. From the equator to 20 degrees north, the ISS will not be visible at all. They can see you during the daytime, but you can't see them. From the equator to 45 degrees south, the International Space Station will be in your evening sky for most of the week, perhaps through November 9th or so. South of 45 degrees south, the ISS will not be visible at all. To determine where it will be in your sky, go to the website heavens-above.com and enter your location, then click on ISS. I have been reviewing a self-published book that I wrote in 1985 entitled A Decade of Comets. It is a study of the 33 comets visually discovered from 1975 through 1984. The series began in podcast 34. The book has 6 parts, and this week we finish part 5, The Discoverers. The book is available free from my website, donmachholz.com, and it is downloadable in sections. This week, download podcast 44, A Decade of Comets, Part 5. If you downloaded it last week for podcast 43, there is no need to download it again as it is the same part as last week. We pick up on page 89, the number of hours it takes to find a comet. In late 1974, as I was considering searching for comets, the question I wanted answered was, how many hours of searching does it take to find a comet? The range could be anywhere from 0 through never, and I did not personally know anyone who had ever discovered a comet. So I read books. One interesting book is Comets, Meteorites, and Men by Peter Lancaster Brown. I read that book cover to cover, and I was inspired by it. It said it takes between 100 and 200 hours of searching to find a comet. Another book that covers many topics and is a classic was written by James Murden. It is the Amateur Astronomer Handbook. It said it takes about 300 hours to find a comet. Maybe that was true when those books were written, but what was it in the mid-1970s? And then I received the latest copy of Eclipse magazine, the quarterly issue of September to November 1974. In it was an interview with William Bradfield of Australia, who said his first comet took 260 hours over 16 months, and his second took 306 hours over 23 months. So I began to believe, yes, it can still be done, and it takes about 300 hours of searching to find a comet. Table 14 in A Decade of Comets discusses each discoverer for whom I had learned the number of hours, along with the comet they discovered, the telescope they used, and the number of hours. Now, when I wrote the book in 1985, I had the number of hours data for only 31 of the 45 discovery events. The average that I came up with is 287 hours. And when I subtracted the highest and lowest, I got 245 hours. Since 1985, I have accumulated more data, and for those 45 discovery events, I have data on 44 of them. The average I get is 293 hours, and the median is only 139 hours. Now, the median is a halfway point in the number of hours and is so much lower than the average because there are a couple of larger numbers that raise the average. I raise my guilty hand on this because my 1,700 hours to find my first comet certainly brought up everyone's average. So the literature that I was reading was fairly accurate for those days, about 300 hours. It is no longer true that the average visual comet discovery takes only 300 hours. We are competing for fewer comets due to the automated search programs. I was surprised that almost every comet hunter counts the number of hours they search. Now, we do not do that with our other observing programs, but we do count the comet hunting hours. But not all count the hours in the same way. Some tally each session to the nearest 5 hours. I record to the nearest 15 minutes, and others do to the closest 10, 20, or 30 minutes. Also, when does the clock start and when does it stop? I count only the time my eye is to the eyepiece. So if I start at 3 a.m. and end at 5 a.m., I probably did about 1 hour, 45 minutes, and I record it as such. I do not count setup time, nor the time that I am swinging the telescope back to the original starting line to begin another sweep. I do not count the time I spend checking the star chart for galaxy confirmation. But some do. Some comet hunters use the running clock. Looking at Table 14 in A Decade of Comets, do we see any correlation between the number of hours searched and the size of telescope or binoculars used? I don't. Large telescopes find comets quickly, and large telescopes take a long time to find comets. It should be noted, though, that the telescope listed here is the one used to find the comet, but the comet hunter might have used a variety of telescopes to accumulate the hours. Notably, Rolf Meyer found all 4 of his comets in a total of 190 hours, fewer than 50 hours per find. He was using a 16-inch, that's a 40-centimeter reflector, sweeping only the evening sky in the northern hemisphere. So, what type of instrument is best for finding comets? I once read a magazine article describing the ideal comet hunter, a wide-field 5-inch refractor. As it turned out, only one person, Jose de Silva Campos of South Africa, used one like that to find a comet during this decade. When I wrote the book in 1985, I had instrument data for only 40 of the 45 discovery events. Since then, I've received instrument data on all 45 discovery events, and so this is what we find. The numbers here are slightly higher than what you find in the Decade of Comets because I've added those 5 extra data points. 10 discoveries were made using binoculars, from 7 by 35 binoculars, which can be handheld, to 20 by 120 millimeter binoculars that are about 5 inches across aperture. 20 reflectors were used, the smallest being 4 inches, the largest 19 inches. And that translates to 100 millimeters, the smallest, which is 0.1 meter, through 0.48 meters. As for refractor telescopes, 14 were used. Now, 8 of those discoveries were by William Bradfield. And the aperture range was 3.3 inches through 6-inch apertures. That is 80 millimeters, which is 8 centimeters through 15 centimeters for the refractors. One Schmidt-Cassegrain telescope was used by Merlin Kohler of Quincy, California. That was an 8-inch Schmidt-Cassegrain, that's 20 centimeters in size. Next week, I'll cover the orbits of those 33 comets. Did they have anything in common? Now for the comets you can see this week. The positions, that is, right ascension and declination of these comets, can be found on Podcast 41, Comet Positions. Our one evening sky comet is Comet Howell 88P. It had peaked at about magnitude 8.5 and it is now slowly dimming. It is about 5 degrees south of Jupiter, and it is plotted on Podcast 44, Map 1. In the morning sky, we have Comet C 2020 M3 Atlas, which is about 3 degrees west of M42 in Orion. It is near its peak brightness, too, at about magnitude 8.0. It is plotted on Podcast 44, Map 2. C 2020 S3 Erasmus is presently magnitude 9.5, and it is still more than a month away from perihelion, which is its closest distance to the Sun, at 0.40 astronomical unit. This is a comet worth watching, as it might reach naked eye visibility next month, although its elongation, the distance in degrees from the sun seen from the Earth, will be decreasing between now and then. It is plotted on podcast 44, map 2. Now for fun with the marathon. The Messier Marathon is typically held in late March of each year. That is the best time of the year to find and observe the 110 galaxies, star clusters, and nebula cataloged by Charles Messier in the late 1700s. But the Messier Marathon can be held any night of the year, with the result being fewer numbers of objects seen. This month, the new moon is on November 15th. The weekend is November 14th, a Saturday, and the 15th, a Sunday. So what would the Messier Marathon be like on the night of November 14th? You will be very busy in the first half hour after evening twilight. We will be looking in the southwest first. I would begin with M6 and M7, then move north to M107, 110, and 12. Then back south again for M69, 70, and 54. Then work your way up to M8. And don't forget M14 over near the equator. Work eastward through M72, 73, 75, 30, 2, and 15. Then north to the objects in Cygnus and Lyra. Get M13 and M92 before they set, but they will be also visible in the morning sky if you miss them now. Continue north through Cassiopeia for M52 and M103, then through Andromeda in south to M33, 74, and 77. By now, the winter Milky Way objects are rising in the east. 2 hours after you start, if you found everything above the horizon, you will have found about 58 of the 110 objects. This is less than average, which is about 67 objects, but the number of objects rising in the east are few and far between. This is rare, but you could take a 7-hour nap if you wanted to, and then get up to see about 45 more objects. But now your final 2 hours before twilight will be very busy as you finish up the Milky Way objects and head over to the Big Dipper area and its many Messier objects, then down through Leo and Virgo. You have plenty of time to pick up those galaxies and even pick up M104 and M68 rising in the southeast. At the end of the night, you could have 104 objects, missing only M4, 80, 19, and 62 in the evening sky, and M83 and M5 in the morning sky. M83, the galaxy, rises about the same time as M5, which is at twilight, but it is faint and diffuse and unlikely to be visible. M5 might be visible in the east in morning twilight. This is similar to the challenge of finding M30 during the late March Messier Marathon. You have been listening to Looking Up with Don, podcast episode 44 for November 4th, 2020. I'm Don Machlotz. Once again, the related website for this podcast is donmacholz.com. That is spelled DONMACHHOLZ.com, 2 H's. From that website, you can read the discovery stories of each of my comet discoveries, and also you can pick up these podcast handouts. You can reach me at this email address, dontheastronomer@gmail.com. Once again, I can be reached at dontheastronomer@gmail.com. God willing and pod willing, I'll be back next week for another episode of Looking Up with Don. We will discuss what's going on in the night sky and the orbits of those comets found between 1975 and 85. What do they have in common, if anything? All that and more. Thank you for listening. See the sky this week. I'll see you next week.